Okay, today we're looking at triangular distributions. Let's get started. So, we use this if there's a range of values, but a particular time in that range is considered more likely. Or it doesn't have to be a time, some sort of measurement, right? So, for example, you're going to be given a min, you're going to be given a max, and you're going to be given a peak. Now, the peak might not be in the middle. It might be, let's say it's here. Okay. Now, we know this is the most likely. We know that this is come down basically to 0, and that anything past there is definitely 0, right? So that's a minimum, that's a peak, that's a max. What's a natural shape to draw? Boom, a triangle, right? Hence the triangular distribution. So you'll be given 3 numbers: max, a min, and a peak. Most likely is one way they might say it. Okay, so let's have a look. E.g., my doctor could take me any time from 2 minutes to 10 minutes. Most likely 5, so 5's probably about here, isn't it, right? So we would just go boom, boom, boom. Now, the thing is, do we know the height there? Well, actually, all our stuff comes from the fact that, seeing as it's got to be somewhere in that range, then the area of that triangle, which represents the probability, or all the probabilities have to add up to 1. Otherwise, there's something we haven't counted, right? So the area of that triangle is 1. We know the length of the base, so we can actually work out the height. Now, you could do this without your formula sheet, but they're going to give you one anyway, so let's use it. So just remember this: probability equals area on my graph. That is the most important thing to remember. Now, your formulas are not going to give you the area, so your formulas don't give you the answer. The formulas give you the height, okay? The formulas give you the height. So formula sheet says what? Okay, let's have a look. So first off, which formula tells you how high is the highest part of this triangle? Now this one's off by itself a little bit, but see where the highest part of that triangle is? See a little dotted line going over? So the height of that triangle is given by that formula there. Oh yeah. Okay, so what's this bit talking about? Right, well, it says that x is in between A and C. Well, there's A, there's C, so any x, any height that we wanted to work out that was somewhere in there, say, that place, we will go and it will be in there, so it's in there, so we use that formula. And remember, that's the height. Now, obviously, you know how to work out the area of a triangle, right? Half base times height is the area, which is also the probability, okay? Good. Boom, you got it. You're smart people. I'm glad. Right. C, X is somewhere. It's greater than C. So it's on this side of C. It's less than B. So it's on that. So somewhere in here, if we're in there, we use that formula, right? Okay. So that, if you see that, we're talking about in here. So we use that formula there. Okay. Now, if you are particularly cunning, what you might do is this. You would walk into your exam and you think, right, there might be something about triangular distribution. I find this sheet confusing. So first off, that first line is just saying where x is less than a. So this bit over here, basically saying the height is 0. Yeah, no surprises there, Sherlock. Right, and then this bit at the bottom, that's saying that above b, x is 0, right? So we don't need that either. Now, these two formulas, we could actually draw little lines showing us where to put them, right? So this one here applies, this one applies there, that one applies there. Notice it's the minus a goes on the A side, the B's go over this side, right? Go over this side.